Okay, hi everyone, welcome to lesson 10. So we will talk about couples and equivalent system for today's lesson. So let's get started by talk a little bit about what's a couples. Okay. So couples is defined as a two parallel force. So two parallel forces that have the same magnitude but just opposite directions. And they are separated by a perpendicular distance d. Okay. We have two forces with the same magnitude but opposite direction. Okay, the distance is d, and then we call these two forces as a couple. So a very example of the couples in your daily life is that imagine you are driving a car with both hands on the steering wheel and you are making a turn. Okay, one hand will push up the wheel as well as the other hand will push down, which causes the steering wheel to rotate. Okay, let's just assume the force from your two hands is the same. It's same but in the other direction, and the effect of the couple will be causing the steering wheel to move. So the movement, okay, produced by a couple is called a couple movement. Okay, this one is called a couple, and the zoom movement will be couple movement, and the movement will be direction RB cross F plus RA cross negative F. Okay, and it will be RB minus RA cross F, and RB minus RA will be the R. Okay, the R will be distance between direction between the two forces. So what's the equivalent couple? Suppose here is a well. You have two forces, which is 30 Newton, 30 Newton. The distance is 0.4 meter. And you have another same well, but the force acting on this point. The force is 40 Newton. And another 40 Newton. And the distance is 0.3 meter. Okay, so we call, what's the moment of the first one? Let's call this A, let's call this B. The moment here will be 30 times 0.4 is 12 Newton meter. And the moment here is 40 times 0.3 is also 12 Newton meter. We call these two as equivalent couples, okay, because the two couples produce a moment with the same magnitude and direction. Okay, we call those as equivalent couples. So, example 1, we have two couples acting on the beam with the geometry as shown in the figure, and the magnitude of the F. Okay, please find the magnitude of F, so the resultant couple moment is 1.5 kilonewton meter clockwise. Okay, so first, let's add the two couples to find the resultant couples, and equivalent the net moment to 1.5 clockwise to find the F. So the net moment is equal to sum of the moment F times by 0.9, the distance between the F two forces. And this one, this couple is clockwise, so that's why we put the negative. And for the 2 kilonewton force, it distance 0.3 meter. The couple moment will be 2 times 0.3, and the direction will be positive, okay, because this couple is counterclockwise, which means 0.9 negative times by F plus 0.6 equals, we want to make the resultant couple as 1.5 negative. That's why we can have this equation. So after we solve equation, we can find the F will be 2.33 kilonewton. Okay, let's solve how we solve this problem. Problem 2. Okay, the two couples acting on the beam with the geometry show the D is 4 feet. Let's find the resultant couple. So as we described before, the distance should be between the two forces we use to calculate the moment should be the perpendicular distance. So what's the perpendicular distance between the 250 lab and the 80 lab? We can now read it directly from the figure. So how should we solve this problem? So here's the plan. So let's resolve the force in X and Y direction first, and then add the two couples to find the resultant couples. Okay. So first, let's look at the 250 labs forces. We found its X and Y component. Okay. The X component will be 50 lab times by cosine theta. That's the vertical up. Okay. For in the Y direction, and X direction will be 50 times sine 30, which is to the right. So my next question will be, does both of the components from couple with their matching components of the other 50 force? The answer is no. It's like only the 43.3, the vertical up. These two cause the couples. What happened to the other? For the y-x direction, a distance will be 0. It doesn't cause any moment. Okay, so that's why we only need to consider like the 43 times 43 times by its perpendicular distance is 3. That's a moment, couple moment magnitude. And is this positive or negative? Here is the force direction. Moment will be clockwise, which is negative. Okay. What about the other two? Force 80 labs. Same thing. Let's first get its y component and x component. Its y component will be eta times 3/5. Okay, we have two. Here the y two force for the x. It will be this one. This direction. So does both our components create a couple with our components on of the other 80 labs? So let's draw it here. So the answer is no. Only this two force becomes a couple. Okay, because for this two force, the direction line is the same, doesn't create any couple or any moment. So for the force coupled in this direction, its movement will be counterclockwise, which means it will be positive. So the final answer will be 43 times 3 times by 3 is negative, and also 43 times by 4 is positive. Let's summarize this together. Here is the final answer. Okay. Example 3. We have a 2D force system with geometry as shown in the figure. So find the equivalent resultant force and a couple acting at the point A, and what's the equivalent single force location measured from A. So first, let's sum out the x and the y components of the force to find the FRA, and then find and sum out the components, sum out the movement, okay, resulting from moving each force to component A and shift FRA to the distance D to make that D equals to MRA over FRY. Okay, first let's sum out the x and the y component. FRX, FRY, I think you should be already very familiar with this one. And for the sum of moment on RA, it will be 200 times 3, okay, which is the distance, and it's positive, and 50 lap times by cosine 30, and distance will be 3 plus 3 plus 3, which becomes 9 here, and 100 times by 4 over 5 times by 6. So what about the 50 lap is 50 lap? It also has a component on the x direction, but however, the point A is just on the x component action of line, which means distance will be 0 and then the moment will be 0. So same thing for 100 lap. We don't consider its component on the x direction when we are calculating the moment. So and then we solve the FR and the theta. So you should be, that's something we already discussed before. So how to find the equivalent single force? Okay. And we already know only the y component causes the moment on point A. So which means we need to use the total moment over the FRY to find distance. Okay, which means if you want to replace all the 3 force with a single force FR, its magnitude is here, its direction is here, but where should we place the resultant force FR? We should place it here, somewhere here, to make sure its distance to point A is 3.12 feet. Okay, that's the meaning of the distance, 3.12 feet. Let's take a look at another very similar example. So give the loading on the beam and the equivalent force and the location from point A. Okay, from point A. First, we need to convert the distributed load, which can be divided into 2 parts. One is a rectangular loading and one is a triangular loading. Find the FR and this location for each of the distributed loads, and then determine the overall FR and the point loading and its location. For the triangular, FR1 will be 0.5 times by 150 times by the distance 6. It will be 450 lap, and its line of action of x1 will be 2 over 3 times by 6, which is 4 feet from point A. Okay. If you are not familiar with this, you can find those equations in the FE package. Okay. So for the rectangular loading, which is 150, well, with width is 8, so its magnitude will be 150 times 8, 1200 lap, and the distance will be 6 plus 1/2 times by 8. Okay, it will be 10 feet from point A. So the resultant force will be Fr equals to 450 plus 1200, which is 1650 laps. Sum of the moment will be 450 times by distance 4 plus 10 times by 1200. That's the moment. Okay, if you want to replace the two Fr1 and Fr2 with a single Fr, we already know its magnitude is 1650 lap. But where should we place the Fr? It will be FMR equal FRA will be 1650 times by x bar, which equals to the moment of Fr. The distance will be 8.36. Okay, I hope you enjoy this lecture. That's pretty much for today.